Have you ever just stopped and wondered, where does a single raindrop actually go? It's kind of a wild thought. Well, today, that's exactly what we're going to do. We're going to follow one on this epic adventure all the way from a mountaintop down to the sea.
I mean, what kind of story would that little drop of water even tell? Turns out, it's a story of incredible power, of carving up the entire planet, and just constant, relentless change. So yeah, let's dive right in. Okay, so our journey begins way, way up high, up in what they call the headwaters. This is where it all starts, with these tiny little trickles of water. Gravity grabs them and they start to gather, almost like they're on a mission to find the absolute lowest point they can possibly get to.
But here's the thing, a river is almost never a solo act. It's really the main character in this much bigger show called a river system. A good way to picture it is like the trunk of a giant tree. And all the smaller streams and rivers, those are the branches, the tributaries, all feeding into that main trunk. And together, they drain this huge area of land.
So how does this whole network even grow? Well, it starts with the smallest of the small. These are called first-order streams, and they're just these tiny little channels with nothing feeding into them. But then, when two of these little guys meet up, boom, you've got a second-order stream. And when two of those meet, you guessed it, a third-order stream. And it just keeps going like that. It's this kind of beautiful, simple math that takes all these tiny beginnings and combines them into something, well, something mighty.
All right, let's follow our river into the next stage of its life. It's gathered a ton of water now, and as it starts to tumble down from the highlands, it enters what geologists call its youthful phase. And trust me, youthful here means full of raw energy and some serious power.
And in this youthful stage, the river is an absolute force to be reckoned with. The slope is super steep, right? So the water is just flying, moving incredibly fast and in a pretty straight line. It's basically like a liquid chisel, just carving its way right through solid rock. And this is how we get those incredible deep-cut canyons and V-shaped valleys you see in the mountains. So, you might be wondering, what happens to all that rock it's breaking up? How does it move all that stuff? Well, it mostly does it in two ways. First, you've got the bed load. This is the heavy-duty material. We're talking boulders, gravel, stuff that gets rolled and bounced and dragged along the bottom. Then there's the suspended load. This is all the lighter stuff, the fine silt and clay, that's just sort of floating in the water, pretty much just along for the ride. Okay, so after all that youthful energy tearing through the mountains, our river starts to grow up. It moves into its mature phase. And here, everything changes. The land flattens out, the river slows way down, and its whole personality just transforms. This is where it becomes what we call a meandering river. Instead of that straight, powerful line, it starts to wander. It makes these big, lazy, looping curves across the landscape. And yeah, there's a technical term for it, sinuosity. It's just a measure of how curvy the river is. The higher the sinuosity, the more it twists and turns. And this leads to one of the absolute coolest things that rivers do. As it winds back and forth, the water erodes the outside of a curve and drops sediment on the inside. So what happens? The loops get wider and wider, and the little neck of land between two bends gets narrower and narrower. Eventually, usually during a flood, the river just says, forget this, and takes a shortcut, punching a new, straighter channel. And that old loop, it gets cut off, abandoned, and left behind as this perfect little U-shaped lake, an oxbow lake. It's amazing. Now, this whole meandering dance takes place on a special stage that the river actually built for itself. It's called a floodplain. It's this super wide, flat valley made up of all the fine silt and sand the river has dropped over thousands of years. And during those floods, the river also builds up its own banks, which we call natural levees. Sometimes water gets trapped behind those levees, creating these marshy, wetland areas called backswamps. And all this talk about floodplains brings us to a really crucial and, yeah, often destructive part of a river's life, floods. But it's so important to remember this isn't some mistake or accident. Flooding is a totally natural, even essential part of what a healthy river does. So what is a flood, really? It's just what happens when there's more water flowing in the river, that's the discharge, than the channel can actually hold. The extra water has to go somewhere, so it spills over the banks and spreads out across, you guessed it, the floodplain. In fact, that's literally how the floodplain gets built and why its soil is so incredibly rich and fertile. You probably heard people talk about a 100-year flood, right? Well, that term is seriously misleading. It does not mean a flood that only happens once a century. Not at all. It's a statistical term. It means that in any given year, there's a 1 in 100 or a 1% chance of a flood that big happening. You could totally have two 100-year floods in a row. It's all about probability. So naturally, since we humans love to build our biggest cities right on these super fertile but also super flood-prone plains, we've spent centuries trying to tame these mighty rivers. And that has led to a really complex and, let's be honest, often difficult relationship between us and the flow of water.
Let's just take levees, for instance. The idea seems simple enough, right? Build a wall, keep the water in, protect the city. But, and this is a big but, there are some major unintended consequences. When you squeeze the river like that, the water level actually gets higher, and it moves way faster. So now the flood risk for towns downstream is even worse. Plus, you're starving the floodplain of all that rich sediment it needs. It's really a classic case of a so-called solution, just creating a whole new set of problems.
The takeaway here is that flood control is a massive, massive challenge, and our thinking about it is starting to evolve. We're slowly moving away from thinking that we can just build our way out of the problem with dams and walls. Now the toolkit is much bigger. It includes smarter ideas, like giving the river room to flood safely, restoring wetlands that act like natural sponges, and of course, using really good forecasting systems to give people a heads up when trouble is coming. And with that, we've arrived at the end of the line, the final destination. After traveling, in some cases, thousands of miles, carrying all that water and all that sediment, our river finally meets the sea. This is it. This is where the river's long job of carrying sediment finally comes to an end. Now, it's really important to make a distinction here. A delta is different from something called an alluvial fan, even though they can look kind of similar. An alluvial fan forms on dry land, like when a mountain stream hits a flat valley. But a delta only forms when a river empties into a big body of standing water, like an ocean or a lake. The very moment that river current hits the still water of the ocean, it's like it hits a wall. It loses all its energy, and it just can't hold on to all that sediment anymore. So it drops everything. All the silts, all the clay, everything it's been carrying on its entire journey gets deposited right there. And over thousands and thousands of years, that sediment builds up, layer upon layer, creating this massive, incredibly fertile new piece of land, the delta. And deltas, you guys, are so incredibly important to human history. The Nile Delta is the perfect example. Think about it. Its unbelievably rich soils, which were replenished every single year by floods, provided everything needed for agriculture to just explode. It's what made the entire ancient Egyptian civilization possible. But here's the thing, deltas aren't just static chunks of land. They are living, breathing, constantly changing environments. Just look at the Mississippi River Delta. It shows you just how dynamic these places are. Over the past 10,000 years, the main channel of the river has jumped course again and again, abandoning old parts of the delta and building new ones. It's constantly reshaping the coast of Louisiana.
And if you want to talk about scale, I mean real scale, look no further than the Ganges-Brahmaputra Delta. This thing is the world's largest delta, and it's home to hundreds of millions of people. It's just this staggering testament to the life-giving power that these landforms have.
So there you have it. From a tiny trickle on a mountaintop to a delta that builds new worlds, the life of a river is this incredible story of creation and change. They've literally sculpted the world we live on and have been the cradle for our civilizations. Which leaves us with one big question, right? As our planet keeps changing, how are we going to adapt to their epic, ongoing journey?